Can you see the screen now?
Yes, sir.
Yes, sir.
The presentation is visible.
Yes, sir.
So by definition, it goes as uh, GIS. Wait a minute, where were we? It's a technological field uh, that incorporates geographical feature with a tabular data. So I have shown you how the tabular data can be attached to a specific feature in GIS, okay? So there are normally three kinds of features. One is a point, another one is a line, and another one is a polygon. So depending on what kind of a feature you are going to use, you can store various different types of data. Okay. So again, this is just an elaboration of our discussion, whatever we have started. So it says that with the GIS, it is possible to map. So ultimately what you will do, you will produce some maps. So those maps will tell your story to the audience that you want to uh, that you want your story to be heard. For example, if you want to map the density of some sort of an animal, okay, in a forest. For example, if you are interested in mapping the rhinos in these conservation forests in Assam, for example, in Kaziranga, or for example, in some of these nearby conservation areas in Pobitara, okay? So you can express all those in sort of some maps. For example, if you are interested in to showing what the areas which are affected by the floods during this time, which is actually happening. So inside these sanctuaries also, there are disasters or natural disasters such as floods. So flood is happening there, and then you can show which areas are affected by floods. So you have to draw a map, and then you can show those areas which are affected by floods in some shades of blue. So that all these things actually are done in a GIS, and then the ultimate goal is you have to produce a map, okay? So you need to produce it some way or the other using different techniques. In order to produce the map is the outcome of your analysis. It may be in a map, it may be in some of the graphs also sometimes. That in order to produce the map, you need to rely upon a model in which the software will depend. That means the model may be also your algorithm. So the model may be a physical based model, it may be a statistical model, or it may be some sort of any other models, a mathematical model mostly. So what is a physical model? In terms of, for example, if you want to map which areas are mostly affected by floods, then you need to know which areas are actually situated at a depression or which areas are situated at an elevation. So for that, you have to give input certain forms of undulations or the DEMs or the DTMs that we have talked in the previous class. So that is one input. And then you also need to show, or you also need to tell the computer that what is the moisture condition of the soil. So if these two parameters are given into the model, and depending on some equations, the model will be run, and then ultimately it will tell you how much of a water, if it falls on this particular DEM, and then if the prerequisite condition or the pre-existing condition of moisture in the soil is this much, will there be any overflow or overland flow of water? So depending on how much overland flow is happening, you will be able to generate the volume of water, and ultimately you will be distributing those water upon a surface, and then you will get those maps. Okay, so this is the model. And at the same time, if you have those outputs, you can query. So as you can see it on the screen, query means you can ask. So if you, what kind of a query you can ask the computer? So you can ask, okay, if this much of a rainfall is happening, this is the moisture condition of the soil. So if my house is situated at this particular location, am I going to be affected by the overland flow, or am I going to be affected by the floods? So this is a kind of query that you are going to ask the system or the GIS. And it will display you the results. So the results may be some sort of a binary results. That means in one or zeros. If it is one, the computer will tell you, okay, yes, your house is affected by the flood waters. Or if it is zero, then you can be sure that you are safe from the waters, something like that. Okay, so basically, this is all about the inherent structure of the system. So it ultimately helps you to answer questions. So remember that you will ask the computer some sort of questions, or it is known as queries. And then depending on the answers, you can take some efficient decisions. So if the computer tells you that, yes, this is if you're going to construct your house in this particular location, and then if this much of a rainfall happens, and this is the soil condition, and this much is the undulations on the ground, then your house will be affected by floods. So ultimately, the decision is yours whether you are going to construct a house in that particular area or not, or that particular point, or that particular location or not. So that system helps you to take efficient decisions. So if you think that it's okay for me to construct my house in a flood area, and then you know that this much of water is going to be coming, I mean, this much of a depth of water is going to be hitting me in this coming days. So this is ultimately your decision, whether you are going to take an efficient decision or not. That depends on the decision maker, but the GIS will give you your queries or answer you with your queries. Okay. So there are three things: geographic, information system, as I have told before. Geographic is meaning is spatial realities of the world. It relates to geography. Okay, spatial means space. Information is, as I said, like it is some form of refined data. And then system is the computer hardware, the software, and the people who are actually engaged with the whole process. Okay. Again, many different people have given or put forward their own definition of GIS. I'm not going to really read those things again, because ultimately these all convey the same meaning. Okay. Let us pick up one short definition. The second one is a powerful set of tools for collection, storing, retrieving, at will, transforming and displaying spatial data from the real world. So Barrow in 1986, who is also known as one of the pioneering fathers of GIS. Actually, I have put one of his books as your reference books. So if you can hold up that book, I suggest you please go through that book. So you will learn many things apart from the class itself. So it is ultimately, it is a powerful set of tools. So he is emphasizing on the part that the collection of data is also a part of GIS. It says, for collection, for storing, and retrieving. So these are the three things. Collection means you collect data, secondary data or primary data, and then you feed to the system. Then you have to store the data. That means even after 10 years, someone wants the data, there is a place that the data is being there. Then retrieve. Retrieve means after 10 years, you can give somebody that data. Okay. At will means whenever or whoever is operating the system, he should be able to do it. And display it also from the real world into the computer screen. Similar definition is last one also. a system for capturing, storing, checking, integrating, manipulating, analyzing, and displaying data which are specially referenced. Do not get, I say, do not be fearful of these long definitions. Ultimately, when you will be doing it by yourself, you'll have your own understanding of what a GIS is. Of course, these definitions will not help you until and unless you just dirty your hands together with the software. Okay, so I'll suggest you have to have the software, and then you have to be playing with the software for much better understanding of the system itself. So there are numerous possibilities that will be opening up for you. And remember, GIS is not any domain specific. So it is not a very vertical technology. It is a cross-discipline specific technology or software or system, whatever you want to say. Because nowadays, GIS is used in almost all the disciplines you can think of. It is used in science, it is used in engineering, it is used in mechanical engineering, it is used in electrical engineering. It is used in social science. Much of the use is happening. Nowadays, climate change is happening. So climate change itself is a multidisciplinary subject where all this informations, you'll have to have some special reference. So for that, GIS is the only tool. So without GIS, you fall short of all these things. You cannot really capture data. You cannot analyze it. And then you cannot really show it in terms of some special reference. Okay, so without GIS, we fall short of all these technological advancements. So again, I will not go into these things. GIS, again, this and this and this and blah, blah, so many things. It has been said, Tomlin, 1990. Okay, so here I will emphasize on one particular abbreviation. This is ESRI, okay? So this is what I was talking about. So ISRI is the company which is actually responsible for developing ArcGIS. So ArcGIS is one very powerful software. I again reiterate you, if you can get a copy of the software, it should be one of your preferred forms of understanding what GIS is. So please try to see in and around you if you can manage to get a software from ISRI. The name of the software is ArcGIS. So they have their own definition. So it says a geographic information system is a computer-based tool for mapping. You know, ultimately you'll have to map something. Mapping is the output, and then in the process you are analyzing things that exist and events that can happen on Earth. So that can happen means you model something which has not yet happened. You model, that means something of an event which is going to happen in future. Okay, you can do it once you have the data, once you know the physical process, and once you have the model, and then once you have the algorithm, and then once you have the technology or the hardware and the software, you can predict the future. Predict the future means not in terms of astrological or that form, but what is the most likely scenario. Okay, so if you have enough data, then you can say, okay, tomorrow if there is going to be a heavy rainfall in my place, of course you can do it. That is how people are predicting in the meteorological departments. So for that, you need to have enough data, which you need to refine it and give it to the system. The system will first store the data, and then all this data will be ultimately be going to some sort of a model. The model will be run by the software, and then the results will be analyzed, and then finally it will be displayed. So ultimately you will come to know that, yes, tomorrow with these conditions existing, I will have this much of a rainfall at my place. Or no, there will be no rainfall at all for the next 2-3 days. So everything is possible. So this is the prediction of future, okay? So that is the definition given by ISRI. They are focusing on this prediction part, and then you say GIS